So a couple of things I want to, just clear up right off the bat. A lot of what I'm going to be talking about the focus has changed a little bit from what I had inside of the pamphlet. I was kind of hoping to get this Delta bot up and running between now and then, but much like the LayerOne badge, I'm still working on it. So, but I did bring a lot of trinkets. This is kind of a little bit of a personal reflection on 3D printing, building these machines, making parts, and just kind of where we're at as far as this technology is concerned. So quick little show of hands around the room. Anybody here using 3D printers effectively right now? So of those of you that just raised your hands, how many of you would say 3D printing is easy? All right, nice, Tacitus. I know a guy. You know a guy. It helps to know a guy. So you hear about 3D printing in the news just about every day. Eagle gets a 3D printed beak. Duck gets a 3D printed foot. There's all sorts of crazy stuff like that. You hear more and more every single day, but you never really see these things out in the wild. So we're starting to approach this junction in technology, and it's just starting to materialize right in front of all of our eyes, and that's what I'm trying to show you guys here. So anyway, a little bit about this bozo up on stage. I'm a part of 23B shop out in Fullerton. If you guys know what's good for you, you will be heading to the after party down there shortly after this talk, or shortly after the next talk, which is the last one of the day. So yeah, like I said, get over to 23B. That's where the party's at tonight. A little bit about where I'm coming from. I have an almost entirely mechanical background. I was working on cars with my dad growing up, and went to trade school. I was always in machine shops all the time, so it just kind of seemed natural. And what was kind of an interesting side effect of learning machine shop is, turns out CNC machinery is almost exactly identical to 3D printers, so it just kind of naturally took me down that way. I work for a SolidWorks reseller. I do 3D CAD and tech support all day long, so I'm lucky enough to say I get to work with 3D printers almost every day. I have some really fancy ones in my office that I walk by all day long, and it's definitely a privilege to be able to work with this kind of cutting edge or extruding edge technology, I guess. So interesting story about how I came into it. About 5 years ago, I was still working in a machine shop, just punching buttons away on the lathe, making part after part all night long. And I was thinking to myself, I was like, you know what? There's a much better way to make things. I figured this out. There's just a more efficient way to do this stuff. So to make a long story short, I wound up at this SolidWorks reseller who also deals with 3D printers, and I happened to be in the right place at the right time. And I was just having lunch with the technical manager one day, and he's like, "Hey, Chris, I hear you guys might need a 3D printer at your hackerspace." My eyes got the size of basketballs. It's like, yeah. So I ended up having to drive up to San Jose, traded the guy a case of nice beer for it. It was a backdoor special, kind of a neat little treat. So anyway, moving along. So if you're not intimately familiar with 3D printers, there's a couple of different technologies out there. I'm just going to give you a quick little breakdown. So what these things really do well is they change the way we manufacture parts. So the old school way of making a part, you'd start out with a, hold on, I need to get a little more booze in me. Better. So the old school way of making parts is you would start out with a big block of solid material and take a cutting tool and connect the dots all the way around until it cuts down into your desired shape. That's what you would call subtractive machining. What 3D printers do is they kind of work in reverse. They're additive. They start from nothing and lay down the very first layer, move up a little bit, and so on and so forth. You guys probably get the idea. But what this is really revolutionary about is how it changes the way we manufacture, both in terms of iterative design, both in terms of like the entire design cycle. So a typical manufacturing process nowadays is you design up your part in 3D CAD software and send off the design to China because that's where it's cheap to make these parts. Whatever, plastic little trinkets. And 6 weeks later, you get your parts back from China, a nice little injection mold, but you screwed up on the print. You missed a dimension or missed a little channel and it doesn't work. So you gotta start all over, revise your print, send it out to China, and 6 weeks later you have your brand new part. So you can imagine going through even one iteration of this is challenging, but typically you go through a few. I'm not sure how many of you guys are in the business of actually making parts, but this is an everyday struggle that us manufacturing geeks have to deal with all day. So what these 3D printers do is first they localize manufacturing and they rapidly increase your turnaround time. So I had a couple of projects I was working on around the shop the last few weeks, and I have some parts in here I'll show you in a little bit, but I had to make a revision to the part, and instead of having to wait 2 weeks, I waited another 6 hours after I punched some buttons, and bam, here's my new part, and it fits the second time around. So it was really kind of a small thing, just a little plastic printed part, but the way it completely takes the effort or the busy work out of making parts, it was really quite a phenomenal thing. However, with these 3D printers, even though they democratize printing a little bit, make it easier for designers to think up parts that were challenging to manufacture previously, you still have a bit of a challenge as far as the time factor is concerned. So that's why these things are called rapid prototyping machines. They're not necessarily rapid manufacturing machines. You get a scaling a penalty that, try and visualize with some numbers here in a minute. If you double the size of a part, you square the surface area, but you cube the volume. So you get an exponential penalty based on the size of your part. Small volumes print much quicker than very large volumes, and that just happens to be a factor of these fused deposition modeling machines, the MakerBot style that lay out a one-dimensional line, layer by layer. Now, with a few different printing technologies, you get the more inkjet type printers that lay down entire sheets of material all at once. And those actually have a volumetric increase. The larger your parts are, the faster they print, because they're printing in entire sheets all at once instead of one single dimension. So as far as the development and background of 3D printers, kind of the origin, it all goes back to just after World War II, when America was starting to become a domestic manufacturing powerhouse. We're making airplane parts and jet parts and tank parts and all sorts of crazy stuff. And we decided that, it was a little tiresome for everybody's grandpa to be cranking handles, making these parts all day long. Let's automate this stuff. So the rise of computers also brought the rise of computer numerical control machines, CNC machines. Right here it's pictured an old school milling machine. So once scientists were able to figure out how to computerize these machines, it goes, oh wow, this makes it much easier to manufacture complex parts. It's a terrible strain on the operator's wrist to be cranking handles all day long when you can have the machines taking care of it for you. So 30 years later, people developed the idea a little bit better. So that's when you see the birth of 3D printing machines in the mid-'80s. 3D Systems is actually a local company. They're up in Placentia? No. Santa Clarita, that area. So they were pretty much the progenitor of the 3D printing technique. They use stereolithography machines, a totally different type. They're using light-cured goo resin, kind of a trippy machine. Anyway, so back in the mid-'80s, 3D Systems standardized the 3D print file standard. If you guys have ever worked with STL file formats, they're a really weird, very basic file type. All it is a point cloud. It's describing 3 points in Cartesian coordinates and a triangle drawn between them. It's just a point cloud with meshes. So you can imagine if you import things incorrectly, you get discontinuous meshes, and that's a big challenge and a completely different talk. So anyway, just keep that in mind. So a few years later, Stratasys comes around and they revolutionize the fused deposition modeling technique, the majority of the printed parts I have up here. That's the RepRap style printer. It's essentially a generic CNC machine. Instead of having a spinning tool on the head, it has a little plastic extruder, kind of like a computerized hot glue gun laying down layer by layer. So 1997, Stratasys comes around, builds up the technology, and only a few years later, the RepRap project starts to gain some traction, and it's been history since then. From the RepRap project, we got our MakerBots, and that's basically what allowed 3D printers to enter our lives and news and, collective consciousness. So as far as where the industry stands right now, kind of a strange thing with MakerBot being sold to Stratasys for $400 million of stock and options. I don't think it was cash last year. But with Stratasys, they're the 800-pound gorilla on the block right now. They have about 50% market share, and big things are starting to come down the pipeline. It's really, really phenomenal. We're still at a strange convergence of this technology right now. With these 3D printers, it's very much like the early days of computing back in the 70s. You either have these large boxes that not everybody can afford to have in their home, or you have these home-built hobbyist pieces of equipment that you have to tinker with and get your nerd friends to get operating, and even then it's a challenge. But we're starting to see this gap close very, very rapidly. One of the neat side effects of this RepRap project and the intense economic curve that you see with these 3D printers. I mean, you can buy these things online now for $700. There's still obviously a challenge to model for and a challenge to control, but for the basic unit, you can get it for, relatively inexpensively. So one thing that's still holding this technology back is the learning curve. So regardless of the integration of technology on these things being, hardware and software and understanding, robotics on a basic level, most people lack 3D CAD skills to make these tools really useful. Like a 3D printer in everybody's home is great if all you're doing is printing stuff off of Thingiverse, right? Like, oh, here's my little bunny, here's my little Yoda, right? Great. But what makes these tools really incredibly useful is the ability to create shapes at will. You say, oh, I need something to hold my, my pasta sauce jars up on the wall, and you can draw a little shape, and an hour and a half later you have that exact little bracket you need for whatever you're doing. And I guess to focus what I'm getting at is there just hasn't been a killer app devised for these printers. There hasn't been anything that really, strikes at everybody's heart that says, oh, I need to get this right now, and it's going to be easy for me to use, and it's going to be something that's useful and fulfilling. So we still have to see what can integrate this technology in a very useful way. Need more beer. So, plenty of room at the bottom. You guys ever hear about this from Richard Feynman? This is a pretty interesting one. So in 1959, Richard Feynman gave a big talk about nanotechnology. He's basically considered the father of nanotechnology. And to summarize what he was getting at, he was saying that there's no real reason in the laws of physics that we know that you can't assemble things molecule by molecule, atom by atom. Obviously, the technology changes a little bit. Gravity isn't as important of a force, but surface tension and van der Waals forces become more important on a small scale. But what is really compelling about his argument is saying there's no reason that we can't assemble things on a very small molecular scale, and we are starting to see the very beginnings of that today. Everybody's familiar with Star Trek replicators. Some of you have probably read some Neil Stephenson in the past. Diamond Age is a great book if you haven't read it yet. And just about every genre of sci-fi has some sort of replicator technology embedded inside of it. And when you really think about like the passions of the human heart, like getting to replicator technology is probably an inevitable happenstance in humanity, right? There's no reason that we will not head that direction. It's only inevitable. Probably not in our lifetimes, but we're going to start to see the beginnings of such things just because of the dramatic impact that these machines and this equipment can have in our day-to-day lives. But whatever you do, just if something's important going on, don't ask for a cup of tea. The Hitchhiker's Guide, have you ever read that? So to reiterate, these 3D printers are a fantastic convergence of technology. You know, it wasn't that long ago that we didn't have the internet in our day-to-day lives, much less in our own our very palms. This robotic technology is becoming more accessible, easier to use. The software is getting better every single day. And it's inevitable that these things, while they may not appear in everybody's kitchen, they will probably be on everybody's street corner or post office or library, something like that. There's such an amazing depth of usage and utility for these machines that people are just starting to discover. This technology is so new that we're just beginning to figure out the uses for this stuff. One compelling argument is that of singularity, with the computing power increase following Moore's law. And basically the slope of the line approaches infinity by about year 2040. Now, that doesn't necessarily say that the robots are going to take over and consume us all, or, you know, they say, oh, that's about when computers will reach the power of the human brain, whatever the heck that means. But I think a more generalized statement in this case is to say that beyond this event of singularity, when that technological curve reaches infinity, we can't see beyond the horizon. We can't even imagine the impacts or the change of our way of life. I mean, everybody's seen how 3D printed parts are starting to show up in biology and medicine. You know, 3D printed ears that are attached to rats running around, or 3D printed veins made out of a sugar lattice. There's crazy stuff going on right now. So, we'll change it up a little bit. Show you a little slideshow of a few things we've been up to. So this was an interesting experiment I was able to go through a few weeks ago at the shop. I needed to make this big 3D printed bracket to hold on to a big electric motor. And I spent about an hour designing this up in CAD and the afternoon printing up the part, only to find out that it didn't fit. And I was about ready to get pretty upset. And then I realized, I was like, wait a minute, I didn't make this the way I'm used to making these kinds of shapes. Like, with the tools I have at the shop, I could probably hack this out in the better part of an afternoon by hand, but it's going to require all of my attention and all of my skill, and the moment I cut too much material off, it's screwed. I can't put it back, right? So when I messed up this part, I was about ready to get upset like I typically do, until I realized I didn't make this the same way I'm used to. I punched a button and walked away and had lunch. Right? Like, it didn't require all my skill and all my attention. So when I screwed it up, it was like, oh man, I measured once and cut twice. That's what happened. So anyway, here's an example of where that part was supposed to fit onto. So I had to make a second iteration. These parts are up here, by the way. My second part, I adjusted the size of the holes and made a thin little gasket rather than printing out the entire part just to check, right? I'm learning from my mistakes. I'm trying to figure out, hey, how can I make this tool useful? How can I make parts in ways that I've never made before? So I just double check my measurements, the holes match up, and I'm saying, okay, bingo, I'm ready to go. And an afternoon later, actually, I let this part print overnight. So I was done, tired, and frustrated, and just got the design out for this one ready to go. And by the time I show up the next morning, parts are there, ready. Here you go. And it's really hard to explain or express the revolutionary design techniques that are allowed with 3D printing. The ability to do this in my garage without a massive machine shop, without, you know, eons of experience and skill involved in this. It was completely mind-boggling to me to consider that this is so easy to do nowadays. Of course, it requires some tools and a little bit of a skill set, but it's easily attainable by anybody in this room. And this stuff's just getting better and more available every single day. So there's a finished part, all bolted up to the little golf cart thing that we had. A few other parts here. Some of them defy. Ooh. let's see. So I'm not sure if you guys have checked out any 3D scanning lately. Oh, you know what? I don't have my little part in here. I'll come back to that. Anyway, so just a quick little anecdote of how my mind was blown about being able to produce parts this way. It was just completely unusual and unknown to me to be able to just give all that frustration up, saying, hey, all the effort that is typically involved in this is just gone. I can forget about it all. So I asked the question earlier, how many of you guys are using your printers effectively? Again, that's really the challenge. Even with my own printer, with the right resources and the right tools at a hackerspace, these things are a challenge to keep running just because they're finicky, they're machines, then there's a lot of different angles that these things are coming at. So the picture up here was one I took about 3 or 4 weeks ago. I went to go visit Noisebridge up in San Francisco. And this was the pile of 3D printers that they had over in the 3D printer corner. And it kind of, it took a little while for me to process all this information, but what it boiled down to was that, hey, these rep wraps and these maker bots came out of hacker spaces. And, you know, if there is a premier hackerspace anywhere in the world, Noisebridge can, you know, jokes aside, it definitely draws some very creative, intelligent, powerful minds. And if at a world-class hackerspace, they can't get these machines up and running reliably, how can anybody in the public be expected to run these things reliably? So it just got me scratching my head thinking about that. Like, what's the big challenge? What is the utility in these things if they just sit dead stacked on top of each other in the corner? So, like I was mentioning earlier, there's a couple of layers of abstraction that keep this technology just barely out of reach. So when I was building this printer here, it definitely helped to have access to a machine shop and machinist knowledge because, hey, I need to have a bunch of screws of certain sizes and all of the rails need to be exactly perfectly the same size. And, you know, if you're focused and really dedicated, you can do that at home with a file, but it helps to have a little bit more extensive resources to get these machines running. So I guess what I'm getting at is this is hard. 3D printers are hard and long. Yeah, you can't see in this picture here, but there's actually just off to the right, there's a 3D printer that has like 36 inches of Z travel. Who knows what they need that for at Noisebridge? So, kind of leaning at this angle with these rep wraps, this is really where this technology becomes diffused through humanity, through society. It's through users like us, people that have a passion to tinker and explore and figure out what these things are useful for. Like, this is what's really going to drive this technology into the mainstream, if it hasn't already reached that. And it's really empowering with the open source, worldwide references that you have on the RepRap website about being able to, you know, just directly download all of the files necessary. And even then, it's still a big challenge because nothing is unified. There's not one complete ecosystem. Of course, you know, a few people get these things up and running, and after, you know, 12 months of toiling away, blood, sweat, and tears, you'll hear everybody with a 3D printer just tell you, yeah, that machine has a bit of my heart and soul in it. Like, literally, there's chunks of me in there. So, what's that?
That happens more often with blades.
Well, you know, those tend to wring you out like a wet cloth. Don't get me started. But what I'm getting at is there's a bunch of different challenges just keeping this out of reach, and it's mostly because this is a culmination. 3D printers are a culmination of a few different esoteric technologies. You know, you need to understand robotics and 3D CAD and G code and I don't know, just have access to pretty wide, diverse resources to make these things fully utilizable in day-to-day life. So exploring on that a little bit, just building these things is a little tough. Like, so this Delta bot up here, this is actually the one of the more advanced designs of 3D printers. It's been out about a year and a half, designed by a Google site engineer. And while these files were all available for me to find online and downloadable, it's still quite a challenge to get everything you need all under one roof. My particular challenge was the bill of materials was completely wrong. Like, the documentation is zilch, and when you need like 700 bolts of different sizes, you can imagine that's a little bit expensive when you order the wrong parts from McMaster-Carr. So, just a little personal experience, just the hardware is challenging enough. I mean, like, you have to search the internet pretty hard to figure out that you have to assemble the triangles, sliding them all in together at the same exact time. It's just little details like that that are left out of the entire process of building these machines that makes it tough to do from a grassroots level. And beyond that, another quick show of hands around the room. How many of you guys out there do 3D CAD of any style, either OpenSCAD or SolidWorks or AutoCAD or whatever? All right, so maybe 20% of you on a good day. And like I was saying before, that's what really empowers this technology, is having the skill to be able to build these shapes and make things directly useful to you right away. Another interesting problem with these open source machines is getting the software toolchain correct. So with my closed source big box machine, luckily I have the right software to run it. It's a closed source engine that all I do is hit slice and it figures out my toolpath automatically. I have like 3 different options. Where with the RepRap style machines, you have this just gigantic diverse ecosystem of all sorts of disparate programs that are a challenge to integrate effectively. So again, going back to the problem with documentation and support, how do you get these things all together from a base level, even with your nerd friends? Like I said, these things, while we hear about them, while we know about them, we don't really see them out in the wild. So we were lucky enough at 23B to get that big used Stratasys for a case of beer. Kind of an interesting story behind that. I'll probably tell you guys later. So they just bought out MakerBot for the vast, unbelievable sum of $400 million. But really, when you consider the market out there, that's just a tiny little speck. Like, MakerBots don't pose a threat to any of the big manufacturers out there, mostly because they're low dollar, they're low end, and nobody's really using them in groundbreaking ways. I mean, every once in a while you hear the story out there like, oh, child with cerebral palsy has 3D printed exoskeleton, something like that. And those are definitely outlier cases and very compelling ones, but very rare do you hear like compelling uses like that every day. And beyond just to expand on the expense problem with these machines is the fact that they lock you down in such a proprietary environment. Yes, it's nice to have something that works all the time, every time, but obviously it's a challenge to figure out why it works nicely every single time. There's obviously a lot of fine-tuning and tweaking. That's what, that makes Strat money. And one interesting experience I had with my machine is, even though my machine is built by the correct people and serviced by the correct people and I have tech support online, like, even then you still have problems. And last year I made the mistake of putting some bad unknown material through it and clogging up my print heads, and this scared the bejesus out of me. So here we have the culprit. You can see over there on the right hand side a nice little clog nozzle, and this is the heart of the machine. This is the most important part of this machine, and also the most irreplaceable part. They obviously don't make these, they don't sell these, they don't want you to keep the old machines around, so I had one shot at getting this thing fixed, and yeah, my heart was pounding a little bit. I'm like, oh, this was so cool, and now it's wrecked and useless. So one nice thing about hackerspaces is it allows you to think outside of the box a little bit. And after I took a look at this, I was like, oh, okay, I know what I did wrong. The material I was using has a shelf life. And it's only good for about 2 years until it sucks so much moisture out of the air that it doesn't extrude the same way. And that's what happened here. It just got clogged up and pounded in the nozzle. So never having seen this before, I kind of figured it out at 23B to just hook this up to a power supply until the entire block heated up enough that I could take out the entire chunk. Like, whew! Crazy fix, unbelievable that it worked, but luckily we were able to get the machine repaired and back up and running, and it's been running about a year since then. So I'll never make that mistake again of putting shit material through there, but just be warned. That's one of the bigger complications with 3D printing in general is just having a good idea of your material quality. You know, does there even a faintest little slick of oil on the outside? Does the diameter change at all? That's important for these little extruder motors. Like if you have varying diameter filament, then the extruders get locked up and things stop working. So again, this goes back to the argument that these machines are so hard to use because there's just so many different layers. You know, if the software is not causing you trouble, the hardware is causing you trouble, or I don't know, once in a while they actually work. So what it really gets down to is that in order to use these machines effectively, you just got to use them. Like, I'm not trying to dissuade anyone from not having a MakerBot because it's really a useful tool. Like, it's like saying, well, why would a very basic computer back in the 70s do me any good? You know, why would a very small calculation benefit me when I could have somebody crank it out by hand on an adding machine? Like, okay, that's probably a little off in left field, but I mean, even just for printing trinkets, like little tiny things that you spend untold hours of your day running to Walmart back and forth to go get, right? Like what these 3D printers start doing is replacing those needs in your life. And you say, hey, you know, I go to this hackerspace all the time that has a kind of a working 3D printer, and I bet I can make a very basic shape that will make my life slightly better. And you do that over and over and over, and suddenly it's like, oh, okay, now I see the utility on these machines. Now I see what they can do for me in my life. So I encourage you guys, get out there, use these machines. So again, the only way to figure out these machines, to really make them useful in your life, is just getting out there and running some parts. You know, learn some OpenSCAD, learn the Thingiverse environment. There's a couple of great websites out there that I download all my 3D models off of. GrabCAD is wonderful. Pardon me, I've had probably my best success with using GrabCAD. That's where I downloaded a bunch of these, you know, skulls and R2-D2 off of. So really, the ecosystem is starting to diversify enough to make it useful for trinkets. One other thing we're starting to see with the software world out there is, I mentioned I work with SolidWorks all day long, and that's a pretty pricey CAD system. But what we're starting to see out in the industry is we're switching from a client-based user model to a more network-based SaaS model. So instead of needing to buy the $5,000 SolidWorks license and having a crazy rig to run that on, now, in the near future, we're going to start to see these technologies open up and become more accessible because software and hardware is becoming cheaper and easier to use. So AutoCAD right now has some cloud-based 3D modeling technologies, and it's really a matter of time until you have several different options to choose from as far as advanced 3D modeling for a very reasonable or free price online. I mean, if you're willing to dedicate the time to learn OpenSCAD, go for it. You know, that'll make these tools ever so much more useful to you. So as far as what the big mainstream industry is starting to look like is Stratasys is starting to gobble up all the little manufacturers. They just acquired a 3D print bureau nearby called Solid Concepts. They were the ones that were in the news recently for the 3D printed metal gun. I'm not sure if you saw that. Built with a crazy laser sintering machine. Cutting edge technology, but whatever. Couple other things, we're starting to see some patents expire. So along with the MakerBot acquisition, the patent that Stratasys holds for the enclosed heated build chamber, I believe that just expired. So now, even though MakerBot is a subset of Stratasys, other companies are going to be able to start to utilize that technology to get, that much further down the road with better, more proven technologies. So all the time people ask, hey, what materials do these printers work in? And for the longest time, it was always ABS plastic, Lego plastic, or PLA, polylactic acid, some even lower end material. But even in my last 18 months on the job, I've seen a dramatic increase in the availability of these materials. Definitely out of the high-end machines, but that just means that the low-end machines are going to follow soon. What we're starting to see is not only ABS plastic, but polycarbonate and biocompatible materials. We're starting to see some that are chemical and temperature resistant, anti-static. The fancier resin printers can print some amazing shapes out of multiple materials at multiple times. You can even have rubber-like materials with different shore hardnesses because they're able to dither the materials throughout the print. It's really, really quite phenomenal what this technology is just starting to figure out. And again, it's such a new implementation of this technology that we haven't quite discovered the most effective uses. What makes our lives, radically different out of, a quick little 3D printed part. It's still the Wild West. So again, I encourage all of you guys to get out there and start using some 3D printers yourself if you're not doing them. Every Thursday night, we're starting to have a 3D print night over at 23B. So if you guys are interested about the technology, I encourage that you come by, and I'm usually there wrenching and working on stuff. So yeah, just get out, get your hands wet, use these machines and figure out what they're useful for, because just like learning the skill of lockpicking, the first time this skill is useful to you, it's an incredible, valuable resource that you'll go back to time and time again and impress your friends and that stuff. So, Creepy Dolan. Okay, this is a little timestamp here, just checking on how we're doing. Got some more pictures for you. I really want to find that 3D scan of my buddy. Where'd it go? So this is an interesting culmination of the technology. This is a scan of my buddy Josh. He was the one that hooked me up with a printer in the first place. He's the technical manager for a 3D printer service bureau. So this guy deals with these all day, every day. And he came by the shop a few weeks ago, and I was talking to him about the things we've been doing. And Mr. Bot, are you still in the room? You're back there. Mr. Bot came by a few weeks ago and says, hey, let's do some 3D scanning. I saw this really crazy thing. And we went out to Best Buy, picked up a Microsoft Kinect, and downloaded the free Microsoft SDK for the Kinect. And we were able to 3D scan my buddy just sitting in the chair. It was slow. My hardware wasn't optimized for this, but with $100 of commodity hardware and freeware, we used Skynet to be able to accomplish this. Within moments, we were able to get a nice, solid, watertight 3D model of a dude just sitting right in front of me, and a half an hour later, we were able to 3D print this part. And this guy's mind was blown. This guy deals with 3D printers all day long. He'd never seen technology like this. Like, you see 3D scanners all day long online, what's the next engine cost that comes along with a MakerBot? It's $3,000, right? And this $100 Microsoft Kinect can keep up with every bit of it as long as you have the hardware that can run it. It's quite phenomenal. I don't know about you guys, Dolan gives me the creeps. So, extrapolate this information a little bit, right? Like 10 years ago, nobody heard about 3D printing. Maybe a tiny little blip on the radar once in a while. Nowadays, you're starting to hear about it more and more and more. And like I was getting at earlier, this isn't going away anytime soon. We're going to see this every day, all day, in unbelievable ways. This is still the 70s of computing. You know, we got 20, 25 years of advancement until this stuff becomes so good that we have, you know, 3D printing submolecular level robots that can auto-assemble everything, you know, on a moment's whim. Who knows? You guys read sci-fi, you know what's capable. You know, 15 years ago, we couldn't fathom that everybody would be walking around with an internet-connected smartphone. And sure enough, you know, society just drives technology down that way because we need it for some reason. And it's really hard to argue a reason why we do not need 3D printing. It just changes the way we make things. It changes the way we need things. It changes so many things about the way we make in our life that, I don't know, you just need to jump on the bandwagon right now. You need to see what this is going to do and how it's going to change your life. Now, again, what's beyond the horizon? What's past the point where we can see how this technology is going to develop? So, this is a 3D print in silicon. I just found this on the internet. I don't even know if there's a date associated with this. But MEMS is microelectrical mechanical systems. This is where 3D printing can really take off. This is where you start building those, you know, nanoscale bots. It has a little bunny here with a little scale. It's 5 micrometers. And just for a sense of scale, 5 micrometers is the size of a red blood cell. So this is technology that's, you know, 15 years behind us. We can do so much better than this today. You know, what are we going to use this for? You know, the little tiny, you know, nanite bots that fly around and turn you into pink ooze, like that's probably not what's going to be just down the road. But, you know, what are the implications of being able to manufacture on a molecular scale? What does this do for the way we make everything in our life? It's hard to say. So one interesting thing that we've seen these 3D printers used for as far as the additive laser sintering technology is some crazy rocket parts. Now, with the laser sintering technology, what they're using is finely powdered metal and a high-powered laser beam to scribe out every single layer, weld it, and fuse it all together. But what's neat about that is suddenly you can work with metals that were much more challenging to use in any other way. Titanium and Inconel and stainless steel. Very, very challenging materials to cut away with a traditional tool are much easier to build up from the ground up using a laser sintering machine. And this all ties in with, like, who's going to figure out the killer app? What's the next great application for this technology? I mean, we're able to build rocket nozzles with complex geometries with about 5% of the traditional effort nowadays. And same thing is true for, you know, airplane parts and medical parts. You know, the more this technology is getting used, the more dramatically it changes the world underneath our noses. The DefCAD project, you guys, I'm sure you've seen a shape like this, right? So, interesting anecdote with this one. This shit doesn't work. This stuff is awful. Even with the right technology, the right machinery, it still requires a gunsmith's skill to get this thing to work. And even then, it's still plastic. I mean, you guys have seen enough Wile E. Coyote cartoons to know what happens when you shoot a plastic gun, right? So, anyway, I was a little baffled that with the exact same machine the DefCAD project has, with the right software that the DefCAD project has, I couldn't get this thing to work. There were some dimensions that were off. And I had a buddy, Ravine, that was always talking guns with me and always challenging me on the subject. So anyway, I finally cornered him. I said, hey, if the guy that's in charge of this DefCAD project, the 3D printed gun project, if he's so gung-ho about power to the people and, giving this out to the masses, why is he not releasing the engineering files? It doesn't have the dimensional information. All it is a 3D point cloud of this part, right? Why can't I scale it or see what size it's supposed to be? And my buddy says, hey, Chris, do a little Google screen share with me. So I get on his screen and teleconference, and he pulls up a SolidWorks model of the 3D printed gun. I go, you dog, did you seriously spend all this time and reverse engineer this part? He goes, better. I'm a bored grad student in Wisconsin, and I just volunteered to help out on the project, and they said, okay. So I got to talking to him, and I said, okay, I'm not much of a gun guy. I've made a lot of parts, and this thing looks fucking weird, right? Like, this doesn't look like any gun I've ever seen. What the hell's wrong with this thing? And my buddy says, you know what, the funny story, the main designer in charge of this project, he had an electrical engineering background. He'd only been using 3D CAD for about 6 months leading up to this project. So, I don't know, it just looks wonky. It looks like it's going to hurt somebody. So, what's that? It's going to hurt the user. So there's a reason why you haven't seen these things out in the wild. Like you've heard people make a stink about 3D printed guns, but there has never once been a single problem with these out in the wild. That's because they don't exist. It's a unicorn, right? Why would you use a several $1,000 machine to make a subpar part when the actual gun parts are $100? Who knows? So it's a completely null argument to say, oh, we got to regulate 3D printers because they can make firearms. No, they can't. They will never. They just don't work that way. One interesting thing we are starting to see is, yes, okay, 3D printers are a bit of a double-edged sword. Like, oh my God, people can suddenly 3D print parametric dongs. What's the world going to come to? Like, there's very few bad things that come out of these machines. Like, how awful could it be? The worst thing you could ever do is like 3D print a Warhammer figurine and someone's going to be mad about copyright. What's really compelling with what's going on in the world is the Smithsonian is starting to spend a lot of time and energy to 3D scan all of their models. Actually, inside of the Smithsonian, they only have about 1% of their entire collection on display at any given time. And with 3D scanning and 3D printing, what that does is it allows the public to have access to all of those exhibits all of the time. And if you have access to a great 3D printer, you can have it in your hand in an afternoon. What does that mean for the world, right? It's hard to say. We're not seeing that every day, but that kind of technology is available today. And I think that's the most exciting part of all of this. So, what is this all going to, right? Like, okay, we've seen a couple of, dystopian sci-fi movies where the robots take over the world or need humans for raw resources or energy or whatever. Who knows? Who knows where this is going to lead us, right? It's inevitable it's going towards a path of, increasing technology. But what I would say in conclusion is that why don't you guys learn how to talk to some robots? Learn their technology so they don't find a reason to execute you. And they might keep you around because you're a useful repairman or printer, or you can scratch them on the back in ways other robots can't. So, I guess I'm about ready. I'm about good on time. Let's see here. I have some 3D printed parts up here that I've been working on. You guys are welcome to come by and inspect and ask some questions. And I guess I can open up the floor for any particular questions. And I actually have some prizes in the back for any questions. And the best question wins this R2-D2 model. So let me go get my little bag of goodies, and we'll do a little Q&A. Bueller?
So, just sort of a question. Do you think the question is really, are we waiting for a killer app, or are we figuring due to the cost of materials? Because at the moment, there's a lot of, the plastics you extrude cost a lot of money. So what I'm wondering is the question more, are we waiting for rather a killer app, or the killer app for keeping materials for 3D printers so that printing trinkets costs less than just going to sort of buying them?
That's a really good question. The question was, to paraphrase, is the real killer app hang up the cost of materials?
Yeah.
So yes, there is a pretty significant material cost. For me, with my industrial box, it costs about $5 a cubic inch. So a part like this is probably a $50 part altogether. So it's not expensive, but it's non-trivial, especially if you screw stuff up. So if you're working on a MakerBot, the material cost is about 1/5 of that. It would be about $10 worth of plastic. So that's the way we're starting to see things develop. As the materials become more commonplace, as the use becomes more common, then we'll probably see a much more dramatic drop in prices. So, catch. Oh. There. All right.
So you talk about the cost associated, especially if you make an error. I remember you had a project with a little 10-pin rotary encoder sleeve you had to build, and one of the times you built it, everything was off because your software thought it needed support material where it was an hole. So talk about that, because that was an awesome project.
There you go. All right, so I do have these pictures here. Give me just a second to pull them up. So I've made this mistake more than once. I've printed out some parts that I didn't measure quite so accurately. Give me just a second. Let me access these in here. I know they're in here somewhere. Yeah, it's on the blog. Anyway, oh, it's fine. Yeah. So my problem was I would take a picture of the bolt hole spacing and import the picture into SolidWorks, and I would just basically space out the holes. I would say, okay, I have a known dimension here, and I can set them all at a known dimension. Taking just a picture isn't enough, even with a known dimension. You actually have to take some measurements across the little holes, and that was the same exact thing that I had happen with my big 3D printed bracket. I tried to do the same thing with a known dimension, and the holes were wrong, so I just had to measure twice and cut once.
But why did the machine think it needed support material inside of the...
Oh.
That one specifically. But...
Okay, yeah, that's a more specific question. So that had to do with the slicing software misinterpreting the, yeah, thanks. It had to do with the slicing software misinterpreting the wall thicknesses of the part. So what I ended up seeing was the wall thicknesses were smaller than the minimum value, and that caused some errors in the slicing software. Let's see, that's the part. I'm just trying to, I don't think I had all the little diagrams saved for it. So, yeah, whoops. There's the part, but I don't have the example you're talking about. You got another question?
Yeah. So, do you think that you could solve the measure once cut twice problem by using those 3D scanners you're talking about? Say, scan the motor first and basically virtually prototype the part before you print it.
Actually, I experienced a more specific error. It's a layer 8 PEBCAC error. So there's just a short between the headphones. That's my own problem. Here, you get the dog face.
So you delivered several comments about MakerBot. What would you recommend for someone who is looking to get into 3D printing?
Use whatever you think you will use. Like, even if it's the most base level, cheapest thing, as long as you're getting your hands dirty, go for it. Like, how much more can I possibly encourage that? Like, you're going to have to start at the bottom and feel a little bit of frustration, but the more you use it, the more you'll learn, the more you'll figure out what this stuff is really good for.
Manufacturing space and use zero gravity environments to get all the bubbles and things out of objects. Would the getting down to the nanobot level overcome those same issues, or would we still have problems with gravity?
So you get new problems at the molecular scale, and it's not something I'm necessarily an expert on, but you get something called the sticky fingers problem, where when you're trying to assemble things molecule by molecule, suddenly the individual molecule you're manipulating sticks to your manipulator in a much different way than you're used to seeing on a macro scale. So, like I said, I'm not an expert on MEMS or nano manufacturing, but you start to see problems that you don't necessarily see in our scale or frame of reference.
Economic changes from disruptive technology like this. But one thing I don't think that was entirely discussed or discussed at all was the potential for ecological consequences for this, because if you've got people who have technology that can make things at will and at whim, the disposability of things is directly correlated to their difficulty or cost of acquisition. And so it becomes very easy for people to just make plastic whenever they need to and then dispose of it. What is that, what are the consequences environmentally of all this plastic being out there?
Well, that's when you reach what you would consider a post-scarcity society, Star Trek society, where you have molecular assemblers and you probably also have molecular disassemblers. You would think that the two would probably go hand in hand, or if they don't go hand in hand. If they don't go hand in hand, well then, I don't know, make that shit work.
What's a good example of where that does go hand in hand in the actual real world right now?
I can't think of a good one offhand. So hey, you got a new mission in life.
What's the value between time and money to melt down old parts or scraps to reuse rather than just buying new plastic?
So, are you familiar with the Great Leap Forward in China? So Mao decided it would be a great idea to reorient industry in China and say, hey, all you agricultural workers, you are now steel workers, and you will now melt down your farm tractors and make steel. Problem is you don't get high quality steel out of melting down your tractors. So it requires a little bit more expertise than just saying, oh, let's melt down all the scrap.
So big, so fast, it doesn't have a chance.
So I actually have a interesting example of a hybrid machine. Good one. So hybrid machines, if you're not familiar, are combination CNC machines and 3D printers. So they can 3D print the shape and also mill out or cut out some of the features, combining the best of both technologies. And what's really cool about those combination hybrid machines is suddenly you have access to basically any shape you want. You have to take a lot of time to manufacture it. You have to take a lot of skill set to produce it correctly, but it's really a compelling argument for what's just down the road, what's just around. So let's see, I'll pull this up. So what this does is it builds up a 3D printed part on a metal base using a big high power laser, and then it comes in afterwards with a CNC milling machine and finishes off all the perfect surfaces, the threaded holes and very flat surfaces that a 3D printer can't do so well. It's what the CNC machine does well. So I guess a different way to look at it is with CNC machinery and 3D printers, they're complementary technologies. They augment what the other does well. Use them and figure out what goes wrong.
Why do they keep breaking?
Because you're a moron.
How far off do you think we are from doing something like prototyping with it?
Prototyping in
Being
terms
able to do a circuit board prototype from the printer.
the technology exists today, it's a matter of implementation. All right, I've exhausted you guys. Thank you for your attention. Whee! Oh, come up here. You get the R2D2.
Chris, can I also have a slingshot?